Hello students. In this short video we're going to show that this combination of complex exponentials reduces to the cosine function. So we're going to write the cosine function, in other words, as a combination of these complex exponentials. This shows up in ordinary differential equations when we are solving second order ODEs, and you get these combinations of exponential functions, and if the roots to your characteristic equation are imaginary, um, then you end up with terms like this one here, and so if you add them together in a certain clever combination, you could write these complex exponentials as a cosine function. So it helps explain why you get sines and cosines in as solutions of your second order ODEs. All right, without further ado, here we go. So what I'm going to do is I'm going to write e to the ix as cosine x plus I sine x, and then e to the minus ix is equal to cosine minus I sine x. And recall that the cosine is an even function, so if you put a minus x in for the cosine, you just get cosine x. That's because cosine is symmetric about the y-axis. And sine x is anti-symmetric about the y-axis. That's a fancy way of saying if you put a minus x in to the sine, you get sine of minus ix. It's an odd function, so the minus sign pops out. And if you think about the sine function, right, it's below the horizontal axis on the left side of 0 and above on the right side of 0. So it's anti-symmetric, where the cosine it's looks the same on either side of 0 when you spin it around the y-axis. Okay, so we say it's symmetric about the y-axis. All right, so now I just need to add these two exponential terms. So that's what I'm going to do. I'm going to add the two exponential terms. That means I have to add together what's happening here on the right hand side, and these imaginary terms are going to disappear, and I'm left with a 2 cosine x, and you can start to see what's happening here with this combination, because I'm going to divide both sides by 2, and sure enough I get that the cosine is equal to the sum of these complex exponentials divided by 2. And so this is a way to write the cosine in terms of complex exponentials. All right, good luck.